Good morning. Today we are looking at some new theorems and definitions from our sections 2.7 and 2.8 in the book. And then we are going to be applying these to some more two-column proofs. So the two new properties that we're going to be looking at are the transitive and substitution properties, and also the reflexive property. So the reflexive property allows us to say that anything is equal or congruent to itself. This is going to become extremely important when we start talking about congruent triangles. And then the transitive property. If A is equal to B and B is equal to C, we can conclude that A equals C. So this is like the chain of reasoning, like the syllogism stuff that you've already seen before. But our supporting statement for that, if we were to do a proof, would be the transitive property. So in this example, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, I can conclude that angle 1 is also congruent to angle 3 by the transitive property. And you could abbreviate that by just saying prop, just to save yourself some writing. Okay. So there was our transitive property. The next one we're going to look at is the substitution property. So substitution is when we replace variables or numbers, but it can be applied to situations like this. If angle 1 is complementary to angle 2, that means they add to 90 degrees. And I'm told that angle 2 is congruent to angle 3, then angle 1 is also complementary to angle 3 by substitution. Because these are congruent angles, we could substitute this angle measure in place of angle 2 and still have complementary angles. So that is substitution. And then one more theorem for today is that vertical angles are congruent. And vertical angles are one that when we have intersecting lines like this, they are opposite from each other. So angle 1 and angle 2 would be vertical angles, and angle 3 and angle 4 would be vertical angles. And therefore they are congruent to each other. So now that we've introduced those couple new theorems and definitions, let's practice them with a proof. So we are given that angle EMH is 40 degrees, EMH, and that's already labeled for us, and that angle CMA is also 40 degrees. I want to prove that angle 1 is congruent to angle CMA. So remember, with two-column proofs, we always want to start with what we're given. And we're given that angle EMH is 40 degrees. That was given to us. Okay. Now, knowing this is 40 degrees, I also know that these are vertical angles from the diagram. So I can say that angle EMH is congruent to angle 1. Why? Because if two angles are vertical angles, then they are congruent. Okay, so these two angles are congruent, so I know that the measure of angle 1 is going to be 40 degrees. And why is that? Because if two angles are congruent, then they have the same measure. Now in your head, you were probably already ready to jump to say that angle 1 was equal to 40 degrees, but remember, if your supporting statement for that is going to be that it's because they're congruent, you have to first address that they're congruent angles and how you know that. So angle 1 is 40 degrees, and then there's one other piece of given information I haven't stated yet, and that was about angle CMA being 40 degrees. So at this point, I've established that angle 1 is 40 degrees and angle CMA is 40 degrees. So I'm ready to conclude that they are congruent angles because if two angles have the same measure, then they are congruent. Okay. All right, let's do another proof. In this example, we have that angle BAC is congruent to angle ACB. So let me mark that on my diagram. BAC is congruent to ACB. Those two angles are congruent. And I'm trying to prove that BAC is congruent to DCE, so this angle over here. So let's start with my given information. BAC is congruent to angle ACB. Now, this angle ACB and the angle we're trying to prove is congruent to BAC are vertical angles. So I can say that that angle ACB is congruent to angle DCE because if two angles are vertical angles, then they are congruent. Okay, so if these two angles are congruent, that tells me that DCE is also congruent to BAC. And that is by the transitive property. One more proof, and this one actually had an error in the way the way the diagram printed, and so I'm going to correct that right now. This triangle was supposed to be touching the line at the bottom, and when it was being changed in the computer, it didn't quite turn out the way it was supposed to. So, MARK, angle 2, angle 3, angle 1. So this is how it's supposed to look. That triangle and the line are supposed to be touching. So we're given that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. So those are my givens. So I'm going to go ahead and get that down as my first statement and reason. And now it's told me I'm trying to prove that angle 1 is supplementary to angle 3. So my next reason it gives me is if two angles form a straight angle, then they are supplementary. Now the two angles we have here that are forming a straight angle are angle 2 and angle 3. So that statement would be that angle 2 is supplementary to angle 3. So we know angle 2 is supplementary to angle 3, and we know that angle 1 is congruent to angle 2. So I can then state that angle 1 is supplementary to angle 3 as well, and this is from substitution. If you look back at that example from the first page, because the measures of angle 1 and angle 2 are the same, we could substitute that measurement in place of angle 2, and they would give us supplementary angles. Okay. Now on the back side, this is going to be something a little bit different. This is some problems with vertical angles that require some algebra skills. We're solving for a variable. So on this first diagram, we have to determine which angles are vertical angles. And so this first angle in here is vertical with 36. So that angle is going to be 36. Then this other angle, this larger angle, is vertical with 64 degrees. So this angle is 64 degrees, which tells me that this wide angle 4x is going to be equal to 64 plus 36. I apologize about that bell. So 4x equals 100, and I get that x is 25. On to the next one. Woo, blurry. Okay. Now this one I have a couple different pieces of information, and I'm trying to find both an x and a y. So I'm told that I've got perpendicular lines, and then I've got another line going through it. So we're going to have to write a system to solve this problem because I've got two different variables. So starting here, this is my straight angle, and if that's perpendicular, that means that this is 90 degrees. And so these two angles together, 2y plus 3x plus 18 equal 90 degrees. All right, and I'm just going to rewrite this in standard form, getting my variables on one side and my constants on the other. Okay, so there's my first equation. Then if I look at my vertical angles here, this angle 3x plus 18 is across from 6y minus 42. So 3x plus 18 equals 6y minus 42. And I'm going to rewrite this one in standard form as well. Get all my variables on one side and all my constants on the other. So here are my two equations in my system. I'm going to rewrite them over here just so we can see them next to each other. So we can use substitution or elimination to solve these. Personally, I think that elimination is going to be easier because if we were going to isolate one of these variables, we'd end up with fractions. So if I've already got 3x and 3x, if I turn one of them negative, then that will cancel. So I'm going to multiply this bottom equation by -1, all three parts. So the top one stays the same, and in the bottom one I get -3x plus 6y equals positive 60. And now I'm going to combine everything on the right and everything on the left. So my x's cancel. That gives me 8y. And on the other side, I get 132. So divide by 8, and I find that y is 16.5. So there's the first part of my answer. Now I need to find x. So I'm going to plug this y value back into one of my equations. So I'll just do this top one here. So 3x plus 2 times 16.5 equals 72. So 3x plus 33 is 72. If I subtract that 33, I'm going to get that 3x equals 39. So x is 13. And there are my two values.